Okay. Okay.
Dan is busy enough.
Yep. Okay.
He is the man to talk to.
Okay. I don't have Oriel's contact information. Okay.
I'll do an intro as a,
Yeah, that'd be
as a
great.
reminder.
Yeah, that'd be great.
Yeah, he was saying that the particular design that you're employing for the white box hyperscale, whatever specifications they gave for that may not be particularly transferable over to your standard install because of the way it's probably was.
Yeah. I know it's not to their standard install.
I know, you know it, isn't it?
Yeah. Yeah, we're ready. All right. Good afternoon, everybody. Welcome to this presentation. We're going to be talking about the Advanced Cooling Facilities Piping System Guideline. So this is a status update on the effort. I'm John Gross with JM Gross Engineering, and I'm also the co-lead for the Advanced Cooling Facilities project.
I'm Mark Dansie, the OCP Ready Facilities Lead. I'm part of the OCP Ready Facility Recognition Program, and we're collaborating with the ACF sub-project.
So the purpose of this this guideline that we're working on is to try to establish a common set of parameters that will allow us to align the facilities infrastructure with the liquid cooling solution. So these would be the three ACS projects, which is rear door, immersion, and cold plate. The intent is to provide kind of a parametric guideline, and it's a performance-based guideline. So the intent here is to provide envelopes of performance. In some cases, there's going to be minimums and maximums, but for the most part, it's an envelope of performance. The idea being that if the facility is designed to supply facility water within that envelope, then it should be compatible with the advanced cooling solutions. Could somebody please close the door back there? So the other important part of this is that, as Mark referenced, I'm going to hand it over to him in just a second, there's a co-location site assessment checklist, and eventually when we get this guideline finished, the guideline is going to feed into a new permutation of the colo site assessment checklist.
Okay, so yeah, we have a current colo site assessment, which is used as part of the OCP Ready Facility Recognition Program. And that site assessment can be used by a colo solution provider that would like to self-certify their data center and to be approved and recognized by the OCP Foundation as OCP Ready. But within the current colo site assessment and within the cooling section, the requirements, e.g. the attributes and the parameters that we created, were based on the requirements of a full stair called Open Rack V1 and V2. Therefore, because it's very important for the OCP Ready Facility Recognition Program to keep pace with innovation, we are collaborating with the ACF sub-project to create, as part of the site assessment, requirements for OCP recognized hardware that is going to be called by liquid cooling, and therefore we need to create a new iteration, and the work that's coming from this work stream, which we are looking for further input from all people within the community, all parts of the community, we can then create this newer site assessment and help with the adoption of OCP recognized equipment.
Thanks. So as I mentioned, the guideline is going to form the foundation for how the ACS systems are going to connect to the facility. We already have guidance out for the actual mechanical connections. That's the piping connections, the types of connections given pipe sizes, and so on and so forth. What we didn't get into last year when we issued that guidance is the performance side of it. So we're talking about temperature ranges, delta T's, delta P's, fluids, so on and so forth. The current state that we have right now is based on engineering best practices and a survey that we conducted with the ACS manufacturers, and we're continuing to work through the evolution of that. So we have 3 different use cases that have to be evaluated and discussed during the effort. So we have existing air-cooled data centers that were designed and built and currently in operation that are looking to be able to retrofit liquid cooling in the future. We have new facilities that are being designed and built right now where the day 1 deployment is going to be air-cooled, and the day 2 configuration will have some amount of liquid cooling in it. And then we have new data centers that are under design and construction now and in the future that are going to be explicitly liquid cooled. So each of those 3 scenarios can look different. The important thing to understand when we talk about this is the boundary discussion. So I've talked about ACF, ACS. ACF, remember, that's the facility side of the conversation. The ACS is the cooling solution side of the conversation. So this boundary looks different depending on where you are. And fundamentally, what you can see here is ACF, as of today, is staying on the facility side of the CDU. So you have solutions where you have CDUs that are internal to the cooling solution. You have solutions that don't have CDUs at all. In those cases where we're sending facility water, that's part of the ACF. Once we get into the point of connection from the facility to the cooling solution, which may or may not include a TCS loop, that's when we hand off to the ACS. For the purposes of this guideline, we're working up to the left-hand side of this boundary. Performance parameters that we're looking at right now include the FWS Temperature Class. For those of you who may or may not be familiar, so FWS is a term defined by ASHRAE as the facility water system. That's basically your primary cooling loop from the data hall out to your cooling plant, whatever that plant may be. So we're focused on FW Temperature Class, which is W17, W27, 32, so on and so forth. We're looking at temperature deltas, and temperature deltas are going to be a function of the temperature class. Certain temperature classes we know are going to require chillers, and so the minimum maximum delta T's that are permitted per the guideline are going to be based on compatibility with chillers. When you get into the higher temperatures where we have chiller list designs, that constraint goes away, and so that's going to look different here. We're looking at system operating pressures, right? So here we're talking about the working pressures, the pressures we expect to see, gauge pressures we expect to see in the system while it's operating. So we're looking to make sure that we have component compatibility, pressure gauges, thermal wells, valves, packings, things like that that are going to be compatible with the pressures that we expect to see. We're going to be looking at differential pressure. That's going to be a function of how much pumping it takes to actually move the fluid through that. Looking at working fluids, materials of construction, pipe connections, and more. So again, as I mentioned, temperature classes. So this is straight out of ASHRAE TC99's thermal guidelines version 5 that was published in May of 2021. And you can get that here. But as I mentioned, W20 or W17 up through W+, that's the 6 water temperature classes. Get into temperature deltas. So as I mentioned here, again, it's tied to the W class. And the reason it's tied to the W class is because of the technology that's likely required in the cooling plant in order to cool that facility water. And are there constraints on your delta T as a function of that cooling plant technology? Maximum operating pressure. So right now, and it's important to know, we're talking about the expected operating pressures, not the working pressure. The working pressure is like the rated pressure of the system. This is when you expect stuff to blow up, okay? We're not talking about that. We're talking about when we're in operation, we have a deadhead condition with the pumps. What is the maximum pressure we expect to see? Right now, there's a lot of synergy around 10 bar. 10 bar is something that is commonly used within the MEP design industry for existing chilled water and facility water systems as a maximum upper limit. We've also found through surveys with the ACS community that a lot, but not all, of the solutions that are designed right now meet this 10 bar. So when we think about retrofit applications, if somebody's going to go and take an ACS solution and they're going to go plug it into an existing data center, and that data center's FWS was designed with a maximum operating pressure of 10 bar, having a package that is installed in that retrofit application that's maybe only good to 6 bar, opens yourself up to some risk. Minimum available differential pressure. So this is a really, really, really important one. And the need for this really came out of the study that we did and the survey that we did of a lot of the ACS manufacturers. What we found is that several of the existing products that are out there were designed for retrofit applications into existing chilled water systems where you might be having 7 to 10 or 11 degrees C supply water coming in, and they have nice low differential pressures in that application. But when you start pushing the water temperatures up to W17, W27, they can mechanically accept that flow through them in order to cool, but the differential pressures got so high that you would actually now have problems where you'd have to replace facility pumps. Who, when they're going to replace, or when they're going to install, say, like a pod of liquid cooling, is going to want to turn around and go to the owner or go to the CFO or whatnot and say, okay, so we're going to install this cluster over here, and this cluster is cold plate and whatnot. But in order to do that, we have to go back to our cooling plant and completely replace all of our facility pumps because we have to generate more head pressure because that thing has a 2.5 bar pressure drop at W27 water. Nobody wants to have that conversation. Then there's also the fact that the energy code kind of says 1 bar is your max. So, but it's important to note that this is going to include all of your valve train, right? So this is the heat exchanger and the entire valve train. Working fluids. We're not going to try to create an exhaustive list of allowable working fluids in the FWS. This goes back to some of how the co-location site assessment checklist is built and filled out.
Okay, so within the colo site assessment, for each attribute, we have a number of parameters that have been decided upon within the community, either an acceptable parameter or an optimum parameter, and the optimum being that the system is working, the most efficiently, the most sustainable way. There's also a selection where you may have a parameter that doesn't fit in either of the numbers, for example, that has been selected, and therefore it would be an exception. So within the colo site assessment, all of the attributes, we need a selection made, and then you will get a result. If there are any exceptions within that list, then it won't meet the requirements. As long as it's acceptable, that's the minimum standard, then it will complete, and therefore you will then be able to go forward and then get OCP ready recognition. So there are some things to learn. Maybe there are things when you do the site assessment, if you're a colo solution provider, where this will actually identify changes that might need to be made depending on your situation. So yeah, that's how we currently have it, and we want to take the same idea forward for the next iteration of the site assessment.
And I would also add that we've got to get the guideline finished. The guideline will then inform the new permutation of the colo site assessment for advanced cooling facilities. And when we get that new colo site assessment created, the intent is to do a presentation to show people how that colo site assessment checklist works.
Yeah, absolutely. Right? And we'll use a number of data centers as part of a pilot program prior to its official launch to make absolutely certain that it works in practice.
Exactly. Yeah. So I think, as we all know, there are an awful lot of options out there for working fluids. We're not going to try to address all of them. We're basically going to identify the optimum solutions, the acceptable solutions, and if it's not in one of those and it's not commonly used, then it's probably going to end up in the exception. Materials of construction is very much the same, right? There's a lot of carbon steel that's used. There's a lot of stainless steel that's used. HDPE, PPR are also used. There's other materials that are used. Again, we're not going to try to be exhaustive on it, but we want the guideline to have enough information in there that people can design, construct, and deploy and operate these piping systems with the best uptime that they can, sustainability, and working with the colo site assessment checklist. Pipe connection methods, I referenced earlier. We issued a guidance last year through the ACF in a white paper. You can get the link or the QR code here. There's a whole lot of mumbo jumbo in there. What it boils down to is DIN 50 and larger is flanged or grooved. DIN 50 or smaller than DIN 50 is threaded BSPP. That's in the guidance right now. We intend on pulling that into the guideline when we go forward, but that's also part of the conversation that we want to have as part of the guideline development. So the call to action, and this is a please, 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 please. I have personally been writing this guideline by myself and haven't been able to get help from the community. I would love help from the community. I'd love help from consulting engineers, manufacturers, from operators, anybody that has experience with piping system design, operation, so on and so forth. Please reach out to me. My email address is here on the slide. Please reach out. I would love to get your assistance so that we can kick this guideline out and get a more community-based input on this guideline. I don't want it to be my guideline. Also, if you want to join ACF, we have bi-weekly calls on Tuesdays at 8 a.m. Pacific time. I'm trying to remember, I can't remember what time that ends up being CET. What is that? That's 5 p.m. CET, I think. Is that right? I think so. And then we've got the QR codes here for the mailing list and the ACF project page. That's all we have for this update on the guideline and the please, please, please call to action. Any questions on what we're working on here or where we're going with this? Is there anybody still awake? Okay, well, if there's no questions, then I guess we'll give the next speaker a little bit more time to get themselves set up. So thank you very much for your time.
Yeah, thanks for your time.